Okay, waves, sound, and light test. What property of the wave is labeled at G? Well, if you go at the resting spot and you go down, this is the height of the wave. This is called the amplitude. What property of the wave is labeled F? The crest is at the top of the wave. What property of the wave is labeled J? From crest to crest is a wavelength. What property of the wave is labeled H? The bottom of the wave is the trough. What type of wave is in the above diagram? Well, the wave is showing oscillations up and down. This is going to be a transverse wave. Frequency is measured in hertz. These are all things that you had to have memorized. Let's go to the next page. What type of wave is represented by the drum in the illustration? Well, a drum gives us sound. Sound needs a medium. The medium is air. Air travels through two types of waves, either longitudinal or compressional. So the answer will be compressional wave. Look at the diagram to answer questions 8 through 10. What part of the wave is labeled G? Right here. G starts here and ends here. You're getting part of a rarefaction, a whole compression, and another part of a rarefaction. This is one wavelength. What part is labeled F? You're getting all of the molecules that are close together. That's a compression. They're going to ask you what is the name of the wave above. This is called a sound wave or longitudinal. So I told everybody to cross out sounds and pick longitudinal. This is also called a compressional wave. Let's look at the drawing below and represents 4 different forms of electromagnetic energy. Letter A shows you this wave, etc. So which one has the shortest wavelength? B has the shortest wavelength, so from crest to crest would be the shortest wavelength. The boy is observing a fish located at position B below the surface of the water. He sees the fish at position A. But it's actually at B. So why does this phenomenon happen? The apparent position of the fish is different from the actual position of the fish. What happens to the light as it passes through the water to cause this difference? When light is passing through a medium, it's going really fast. However, it's going slower as it's going through the water because the molecules are close together. And then once it gets out of the water, it goes really fast so that it looks like it's bent. The person is looking at the fish, thinks it's here, but it's really here. Bending of light, or the apparent bending of light, is refraction. Number 14, a common characteristic of all sound waves. Well, they need a medium, and that medium will be creating vibrations. Number 15, the diagram below shows the relative wavelengths for several types of electromagnetic energy. The longer waves are to the left, and the shorter ones are to the right. What type of electromagnetic energy has shorter wavelength than ultraviolet waves? Well, here are my ultraviolet waves. Shorter, I have to go this way. There are only 2 that are shorter. Those are X-rays. The diagram below shows a light ray. The light is hitting a barrier, striking off the barrier, and bouncing off. This is called a reflection. When viewed from the side, the pencil appears to be broken. What process causes this to happen? Same thing. If it's going through 2 different mediums, it changes its direction and it looks like it's bent. This is called refraction. This is the same phenomena as you saw with the bird. It's not a bird, it was a fish. Number 18, which feature best distinguishes one form of electromagnetic energy from the other? Distinguishes means to differs. So how do they differ? It tells you right up here. That's a long wavelength, that's a short wavelength. That's the only way they differ is through the size of their wavelength. They all travel the same speed, but they all have different wavelengths. When you sit in a room and you can hear noises in the hallway, because sound can spread out and bend around the corner. If sound can bend around the corner, it has the ability to diffract. Why does a stop sign appear red? Everything has its color because of its wavelength, but it doesn't absorb the color red, it actually reflects it. So a red stop sign is every color but red because the red is being reflected. Number 21. Which form of energy is produced when a rubber band vibrates rather? Vibrations are sound. Reflected. We want something that's bouncing off, which would be choice 1. Number 23. Which changes in energy form are illustrated in the diagram? Well, we're starting here with the sun. This is electromagnetic energy, aka otherwise known as light. The light is going into the solar cells and out the wires. The electrical energy is going to be captured in the solar cells and then delivered to the fan, which is going to move around and produce mechanical energy. It'll also make a sound. When it's done, the same thing happens here. 4 is your choice. Sound waves cannot travel through a vacuum because a vacuum is empty space, and sound needs a medium. And finally, question number 25. The picture below shows a bird landing on a bird feeder outside a window. The image of this bird in the window is the result of light being reflected. When you see something, the light bounces off and hits you in the eye. It's reflecting an image. This was the whole part 1. Stay tuned for test corrections for part 2.